Hi, Chelsea. How are you doing?
Hi, sir. I'm good. How are you?
Very good, very good. So today, what do you want to do?
Today, I just have some questions from my Nelson textbook for chapter 6 on radians.
Okay, sure. Share them, then I'll try to answer them.
Okay.
So you can share actually.
Yeah. Can you see my screen?
Yes, I can.
Okay. So first one is question 5.
Okay, slightly small. Can you increase the size a bit? We can read it and then we'll answer. Okay, why don't you read it?
5A, determine the measure of the central angle that is formed by an arc length of 5 centimeters in a circle with a radius of 2.5 centimeters. Express a measure in both radians and degrees, correct to 1 decimal place.
Okay, so let's go slightly slowly. Let's try to sketch and put all the things together. Is it okay?
Yeah.
So determine the measure of central angle. So let's call this angle as theta, which we want to find. That's the central angle. That is formed by an arc length of 5 centimeters. So this is 5 centimeters given to us, arc length. Okay, let's say center is O, we'll label it as we go along, right? O, A, and B. Okay, so arc length of 5 centimeter in a circle with radius of 2.5 centimeters. So 2.5 centimeters. Express the measure of both radian and degree, correct to 1 decimal place. Right. So A equals to R theta. So remember this triangle so that you remember the relation between like speed, distance, time triangle, right? So we say A, arc length is R times theta, right? So what is theta equals to? Theta is equals to arc length over the radius. Is that clear?
Yeah.
Arc length is 5 and the radius is 2.5, and therefore theta is 2 radians. Is that clear to you?
Yes.
So that is so simple to find. But you need to write answer in both degrees and radians. So we got one. So when you work, it is all in radians. Now, how do we convert to degrees?
So
So
now we have to multiply by 180 over pi.
perfect. So it is 2 times 180 over pi. Now, so that is, you can use calculator. Can you calculate and tell me what is the exact answer? I mean,
I got 114.6.
114.6. Okay.
Yeah.
So that will be our answer for part A. Is that clear to you?
Mm-hmm.
Perfect. Can you see what is part B now? Clear on.
Part B. Determine the arc length of the circle in part A if the central angle is 200 degrees.
Okay, so we'll again make this. And this time we are given the central angle as 200 degrees. So tell me once again, what do you really want to find?
The arc length.
For the central angle of 200, correct?
Yes.
Okay, I know central angle 200. I should have made realistically slightly bigger. So let me erase this. Central angle of 200, 200 is more than 180, right?
Mm-hmm.
We're talking about this angle. Do you see that? So that is the central angle which we are looking at, 200 degrees. So anyway, the idea is we have to use the same radius, which is 2.5. R is 2.5. So let's convert the angle into radian measurement. Is that okay? So 200 degrees can be written as equal to pi over 180 degrees, correct? So that becomes radian measurements. And so this is equal to theta in radians. So the arc length will be R times theta. So you can now calculate R is 2.5 times 200 degrees times pi divided by 180. Is that clear to you? Find this.
I got 8.7.
I'll write 8.7, but I'll tell you how to check this answer. Is it okay? And then we will redo if it is wrong. So, well, what is the circumference of the circle with radius of 2.5? Tell me. Circumference will be 2 pi r, right?
Yeah.
So let's calculate circumference. 2 times pi times 2.5. That is 5 times pi, right? Tell me, how much you get this?
Oh, 15.7.
Okay. Now this is the whole circumference, but we are looking into angle of 200, not 360. So from the symmetry of the circle, we can actually also find the arc length in this method. So the arc length, which is major arc for us, let's write this arc as A, B, and let's take a point P. Major arc normally will involve 3 points, right? So we'll say APB will be how much? Circumference is 15.7. Will multiply by 200 degrees and divide by 360 degrees. Do you see in that same ratio? What do you get? Tell me. 15.7 times 200 divided by 360. How much do you get?
8.7.
Do you see you get exactly the same value?
Mm-hmm.
So the idea here is that circle has infinite symmetry. And what we can do here is we can find proportional arc length. So circumference is for the angle of 360 degrees. So I'm multiplying by 200 dividing by 360. So I'm only taking the length, arc length, which is for 200 degrees. Do you see how I calculated without directly converting? Correct. On the other hand, what I did was that this will call case 1 or method 1, right? Which we are going to prefer this method. Convert the degrees to radians. So once you find that, then you multiply r radius with the angle theta and find your answer. Include units and write down the arc length. Is that clear to you?
Yeah.
Perfect. So let's move on and take any other question you want.
My next question was question 11.
Okay, wait. Question number 10. Did you do question number 10? It has been there in test papers. I've seen it in many test papers.
I have not done question 10.
Let's do it. I think your angle is pi by 12. Is it okay? This angle is pi by 12. CE is 4.5, which is written here. CE is 4.5. Determine the size of angle theta and x. So let's look into the triangle ABC. In triangle ABC, can you find the angle theta? That's a right angle triangle. And you are given opposite side and the hypotenuse, correct? So you can use SOHCAHTOA over, right? Sine is opposite over hypotenuse, cos adjacent over hypotenuse, tan opposite over adjacent. And therefore, I can say sine of theta is basically equals to the opposite side of 4 and the hypotenuse of 8, which is half. And now we can find theta as sine inverse of half, right? So, or you can also use special triangle in this particular case. So 1, 2, square root 3, that's a special triangle, 30, 60, 90, or pi by 3, pi by 6. So from pi by 6, we get the value theta as pi by 6, sine is half. Is that okay?
Mm-hmm.
So we know this angle is pi by 6. That means vertically opposite angle is also pi by 6, correct?
Yeah.
Both of them are pi by 6. We're given that smaller one is pi by 12. So the remaining one is how much? The remaining one is pi by 6 minus pi by 12.
Yeah.
So let's calculate that part. So I'm just changing the ink. Okay. So the remaining one is, take blue. So this remaining angle here is pi by 6 minus pi by 12, which is, we can say 2 minus 1 or again. So pi by 12 itself. Is it okay?
Yeah.
Sorry, this is pi by 3. What am I doing? So theta was pi by 6. This is pi by 3. I'm sorry. This will be pi by 3, right? So pi by 3 minus pi by 12. Okay. So in this right angle triangle, this is pi by 6. We calculated. So the other one will be pi by 3, right?
Oh, yeah. Mhm.
So this angle will be pi by 3 minus pi by 12. So 12 and 3, 4, 4 minus 2, 3 pi by 12. 3 pi by 12 is pi by 4. Is it okay? So that angle is pi by 4. So if that is pi by 4 and this is 90 degrees, so what we have here is the other angle will also be pi by 4. It's an isosceles triangle, right angle triangle. So what is x value? X value will be square root 2 times 4.5, correct? You can find like this. So let me make this triangle slightly bigger now. So that it's absolutely clear to you how we got this value. This is a very good question, Chelsea. So, and this is, I'm drawing only this part of the triangle, E, right? E, and then this is F. So it was like this earlier. We know this is pi by 12. And we just calculated this to be pi by 4. Here it is 90. This is also pi by 4. So we have a special triangle. And this length is 4.5. One of the sides is 4.5. So that will be also 4.5. And this will be square root, right? Times 4.5.
Yeah.
Or you could use the trigonometric ratio, sine or cosine, right?
Mhm.
For this, and you can say, well, the value of x is equal to 4.5 divided by cos of pi by 4, correct? So which will be 4.5 square root 2. So that is how you'll find the value of x, correct? So we get both our answers. So the answers are theta is equal to pi by 6 and x is equal to, in centimeters, can you tell me what is the value? 4.5 times square root 2 is how much?
Mm,
Approximately
6.36.
3.6 centimeters. Is that clear to you?
Yes.
So that is how you're going to do question number 10. Okay. So let me clear the screen. Everything is clear?
Yeah.
Let's move on to your question. Which one you were interested in? 11, right?
Yeah.
Yeah, let's see 11. Again, 11 is also an excellent question. I've seen that also in many test papers. Can you please read the question?
Yes. A wind turbine has 3 blades, each measuring 3 meters from center to tip. At a particular time, the turbine is rotating 4 times a minute. A, determine the angular velocity of the turbine in radians per second. And B is, how far has the tip of the blade traveled after 5 minutes?
Perfect. So, so basically, we're looking only at one tip that will give us all the answers. Let's say that is the tip which we are looking into, correct? And we know the length is 3. It says that the wind turbine has 3 blades, each measures 3 meters from center to tip. At a particular time, turbine is rotating 4 times a minute. So one full rotation is taking how much time? 4 times in 1 minute. Do you understand?
Yes.
Or you can say 60 seconds. Is that okay?
Mhm.
So one revolution will take how much? One revolution will be in 60 seconds divided by 4, right? Because there are 4 revolutions in 60 seconds. So we can just divide this. What do you get? 4 times 1 and 5, 15 seconds. Is it okay?
Yeah.
So this is revolutions per second. Do you understand? So we can say that the angular velocity is, it takes 15 seconds for one revolution, right? So in 1 second, how many revolutions?
So we have to
1 over
divide.
15, right? Correct? So time taken for one revolution is 1 over 15. Is that clear to you?
Yes.
Right? But we want in radians per second, right? So one revolution in 15 seconds. One revolution really means what? One revolution means 2 pi radians. Is that
Yeah.
okay?
Yeah. Mhm.
So angular velocity is number of radians per second, right? So in 1 second, how many revolutions we can say, right? So in 15 seconds, one revolution. So that implies that in 1 second, revolutions per second, right? In 1 second would be 1 over 15 revolutions. Is it okay?
Mhm.
And what is revolution? Means the angle is 2 pi, right? So in 1 second, it goes through the angle of 2 pi over 15. So that's radians per second. So we normally write this as omega equals to so many radians per second. Is that clear to you?
Yes.
So that is how we are going to find the speed. So the time period, so basically you can say that omega is 2 pi by time period or frequency, we say. Right? Number of revolutions in 1 second is also called frequency. Is it okay?
Mhm.
So 2 pi by the time taken for one revolution is the angular velocity, or you could do as I did. Is it okay?
Yeah.
Finding out how much time does it take to make one revolution. And or you can say in 1 second, how many revolutions. So radians per second means angle covered in 1 second. In 1 second, how much revolution, right? So in 1 second, it does 1 over 15 revolutions. Each revolution is 2 pi radians. So it does 2 pi over 15 radians. Is that okay?
Yeah.
So we have 2 pi over 15 radians per second as our angular velocity. So this answer is clear to us, which is 2 pi over 15. You can always calculate and write down so many radians per second. Clear?
Mhm.
Now it says, how far the tip of the blade travels in 5 minutes, right? How far will it go in 5 minutes? So in 1 second, I mean, if it travels one revolution, it means 2 pi r is the distance traveled. Is it okay?
Mhm.
So you can also say A is r theta, and then also you'll get the same thing. So what we're trying to say here is, when it says 4 times, we can also calculate from here. 4 times in a minute. We want in 5 minutes, right? So in 5 minutes, it will go how many times? 20 times, correct?
Yeah.
So we'll answer in a very simple way, which is in 5 minutes, it will go 4 times 5, which is 20 times. Is it okay?
Yeah.
So 20 times, if I move this round and round, one round is 2 pi r, correct?
Mhm.
So 2 pi r into 20. So this answer will be 2 pi r into 20. And the radius is given to us as 3. So it'll be 2 pi times 3 times 20. Is that clear to you? In 3 meters. That much of distance it is going to cover, circular distance, in 5 minutes. Is it okay?
Yeah.
So you can
So
just calculate. 4 times 3 is 120 pi meters.
okay.
Do you see how we calculated without using any formula, right? So we really did not use any formula to figure this out. Okay. How will you use the formula and do it? A equals to r theta, right? Now let me show you how we get the same answer using formula. A equals to r theta, correct? R is given to us as 3. And how much is the theta? How many radians it is in 1 minute? It goes how many radians? 4 times piece? In 1 minute, it goes 4 times 2 pi, right?
Yeah.
8 pi radians. Is that okay?
Mhm.
So the total angle will be 5 times this, right? So 5 times 8 is 40. Is that okay? So what do you get? You get 120 pi. The same answer. Do you see this?
Oh, yeah.
So theta will be 5 times this value, 40, right? So 5 times 8, which is 8 pi, which is 40. Do you understand how you got it in radius now?
Mhm.
So either way you could use. Using formula is straightforward. However, the logic also works in this particular case. So either way, you could do it. Is this
Okay.
clear to you? Very important question.
Yeah.
Perfect. So we'll clear this and move on to any other question.
Mm. Number 16.
Okay. So what does it say? Can you please read the question?
The members of a high school basketball team are driving from Calgary to Vancouver, which is a distance of 675 kilometers. Each tire on their van has a radius of 32 centimeters. If the team members drive at a constant speed and cover the distance from Calgary to Vancouver in 6 hours and 45 minutes, what is the angular velocity in radians per second of each tire during the drive?
Okay. So this is not bad. You could actually convert it like this. First thing first, we have to take care of the units. So it is 675 kilometers, right? So let's convert to meters. So it will be so many thousand meters. Is that okay? 1 unit, correct? Now, in one full rotation, how much distance will the tire cover? So we'll make this in meters. So it will be 0.32 meters. Is that okay? So one circle will means 2 pi r, correct? So 2 pi times 0.32 meters. So much is one revolution. So we'll figure out how many revolutions will be done in covering so many meters. Is that okay? Dividing one by the other. So the question here is, each tire on their van has radius of 32 centimeters. If the team members drive at a constant speed and cover the distance from Calgary to Vancouver in 6 hours and 45 minutes, what is the angular velocity? So angular velocity will basically means in radians per second, right? So how many circles it goes through, right? And time is given to us. We can convert this time to seconds and figure it out. Is it okay? So let's first find the number of circles, right? So we'll divide the whole distance, which is 675. So number of revolutions, let me write this number of revolution like this. Is that okay? And we have 675,000 divided by one circle, which is 2 pi times 0.32. Is it okay? Find this answer. You can calculate the circumference separately first, and then we'll divide by that number. Is it okay? 2 pi r. So we'll do 2 times, use the pi value, which is exact value, 0.32. So we have a circumference of approximately 0.20. We'll keep it exact value, right? So that'll be better for us. Okay. And we have 675,000 divided by our answer, and we get this as equal to 33,5717. Is it okay? 0.5. So many revolutions we get. I just calculated. So many revolutions in radians will be multiplied by 2 pi. Do you get the idea? Okay. Now, total time is 6 hours and 45 minutes. Let's convert that to seconds. Is that okay? 6 hours. So do 6 times 24. 6 times 6 hours means 16 to 60 times 60 plus 45 times that 60. Is that okay? So many seconds.
Yeah.
How much do you get? 6 times 60 into 60 plus 45 into 60. 24,300. Is that okay?
Mhm.
So we have done so many circles, right? So many circles in that much of time, correct?
Yes.
If you convert a circle into radian value, basically you're multiplying this by 2 pi, correct? Full circle is 2 pi, correct?
Mhm.
So this is at present in meters. So we'll first find how many, so many circles are there. So that means in radians, it'll be 2 pi times 335,717.5. And we'll divide by this time. Is it okay? So we are
So,
doing radians
sorry, sir, why are we multiplying it again by 2 pi?
because we just found the number of revolutions, number of circles. We did not. So every circle, what we did first is distance was divided by the circumference to see number of revolutions. So we have this number of revolution. Each
Mhm.
revolution makes 2 pi radians.
Yes.
So, so that will make in radians 335,717 times 2 pi. So many radians. And we converted time taken in seconds, which was 243,000.
Mhm.
24300. So that becomes the radians per second speed. So if you calculate this, which is 335717 times 2 times pi equals to, and we are going to divide this by 24300, and that gives you 86.8 radians per second. That is what I get. Did you understand the method? Can you tell me, Chelsea, what I did here?
Yes. So the first thing that you did was converted everything to the same units.
Yes.
So meters, and then changing the hours to seconds.
Correct.
And then you found the circumference by using 2 pi r and then the given radius of 32. And then you found the number of revolutions, which was the distance divided by circumference.
Correct.
Then you multiply that by one revolution is 2 pi.
Correct.
So you multiplied the number that we got by 2 pi, and then you divided it by the number of seconds to
Yeah,
get.
so radians per second. Do you see how logically we approach this problem without getting into intricacies of A equals to R theta? I could have done it with A equals to R I, right? But then it would be very complicated.
Yeah.
Okay.
Mhm.
This is kind of straightforward. Is it okay?
Yeah.
We can also, I'll give you some relations which can help you. Velocity, which is linear velocity, is equals to omega r. I'll show you a shortcut method of doing this. I don't know which one is the right answer. We got this as our answer, correct? Velocity equals to, which this is a linear velocity. Is it okay? And the angular velocity are related with this particular relation. Velocity is omega r. This is not given in your books, but from my calculations, that is what the relation is. You can find the angular velocity, I mean the linear velocity, because you know the distance and you know the time, correct? So if you divide 675,000 by number of seconds, you'll get meters per second. Can you do that? 675,000, we'll do this calculation. 675,000 divided by 2,4,300. 2,4,300 gives you 27.7 recurring.
Yeah.
I'll put 3 decimals. Meters per second. Is it okay?
Mhm.
This is my velocity. Is it okay?
Yeah.
Now to find omega, which is called angular velocity, will be linear velocity divided by r. So if I divide 27.7 recurring by the radius, which is 0.32, what do I get? Divided by 0.32. 86.2 over decimal value of 86.8.
Yeah.
86.8. Did you see that?
That was so much faster.
So that's the correct answer. Do you see that?
Mhm.
But I had to go roundabout because V equals to omega R is a critical formula which is missing from this book. So I didn't use it earlier. But now you know it, right?
Yeah.
So how will you do it? You'll find the linear velocity, distance divided by time, correct? So this
Yeah.
gives me the velocity, distance divided by time in meters per second. And I know angular velocity is linear velocity divided by the radius because V equals to omega R. And as soon as I divide, I get my answer, which is so many radians per second. Done. So both ways, we get the same answer. Do you like
Yes.
it?
It's a good way to check what you got.
But you could do like this in your test paper, right? Because
Yeah.
this is just the right way of doing it. So whenever you are relating angular and the linear velocities, this is a very important formula to remember. Okay, let me clear this screen and write down V equals to omega R, right? So this is your linear velocity and omega equals to V over R. So what is omega? Omega is angular velocity. And V is linear velocity.
Yeah.
So with that, in no time, we have a solution of this. Step number 1, convert to correct unit, find linear velocity in meters per second. Step number 2, divide that by the radius given to you in meters, and you get your answer in radians per second. Is that clear to you?
Mhm.
So with that, we end your last question of the test. Any other questions?
No.
No, perfect. So Chelsea, can you summarize what did you learn today? That's a very important part. So stop sharing and then we will discuss what did we learn. Okay?
Okay.
Yeah. Now,
Uh,
Chelsea, tell me, what did you learn today?
okay. So today we learned how to solve a question when you're given like the angles and the sides, so like a diagram. How to solve that. We also learned how to find angular velocity by using the V equals W times R
Omega, omega. So it's
for
a,
omega. Yeah.
yeah,
That's mostly what we did today. Yeah.
perfect. So we actually saw how do we convert very easily from radians per second if you are given the revolution. Each revolution is 2 pi radians, right? So if I
Yeah.
say in 1 second we do 5 revolution, that means in 1 second it is 5 times 2 pi, 10 pi radians covered. Is that okay? So
Yeah.
10 pi radians per second becomes my angular velocity of the whole circular thing going on. Is it okay? So
Mhm.
many Ferris wheel examples and such example, windmill example, which you did, will require that part. At times, as in the car case, we are always given a distance, and it's a very difficult question actually. So finding linear velocity is simple. You know the distance, you know the time, divide and get the linear velocity. And now linear velocity V is equals to omega times R. Omega times the radius, the radian velocity. Is that okay? The angular velocity. And so relating that, you find angular velocity very easily. So that is how you could do it. Is that okay?
Yeah.
If you go to my YouTube channel, you can just search Anil Kumar Radian Measurements. Measurements, one of our previous classes. Okay, go down. We'll see a playlist, and then now this is 22 minutes video is an excellent video to start. You understand all the relations between arc length, sector area, chord, and segment area. Go further.
I actually watched this already, sir.
So now you see radian measurement trigonometry, and here we have radian arc 16 videos in velocity, angular velocity. Yeah, click the 16 videos. So as you can see, there are all, we can go through this playlist. Just go, there are 75 videos in this particular playlist, which you click. Okay, go down, go further down, almost at the end. Because we are beginning with the concepts, correct? So initially you learn how do you find angle, arc length, radius, and then you get into more and more difficult questions. So can you click that? Okay, steps to convert radians to degrees, go further down. Okay, do this last video, green one. which is 3:42 minutes. Yeah, click this.
This one? Okay.
Yes. So this relates to gear, I think. So let's see this. This is a very important question.
I'm Anil Kumar.
Yeah, can you please read the question?
Yeah. Two gears work together. The smaller gear has a radius of 5 centimeters and the larger gear has a radius of 12 centimeters.
Okay.
Determine the number of radians that the larger gear rotates when the smaller gear rotates 5 pi over 3 radians.
Very interesting question. And I've seen this question many times in test paper. So we have two gears, one big, one small, as normally there is. Like in your bicycle also, there are two gears, right? Attached to the front and back wheel. And it says the smaller gear has a radius of 5 centimeters, larger has 12 centimeters. Determine the number of radians that the larger gear rotates when the smaller gear goes 5 pi by 3, right? So that's a very interesting question. You can watch the video and understand. Can you tell me how will you do it? So they lock in the teeth, right? So number of every teeth will be locked in. So in one full cycle of the small one, it will rotate the other one how many times? That is what you have to figure out. Is it okay?
Yeah.
So go to almost the end of it. We'll have the whole solution in one page. It's a very short video, just 3 minutes. And you see how we have linked the two. The smaller gear, 5 radius, bigger one, 12. And now, when we know this radius, theta is 2 pi by, we know theta is given to us as 5 pi by 3 radians. So we can find the length of the arc, which it moves r into theta, right? By multiplying the two. So we know that much is the distance moved by the smaller gear. Is it okay?
Yes.
So r for the bigger is 12, and we need to find angle through which it rotates. But we know the arc length, which it has to rotate, because after all, that will move the same number of gears, right? So arc length being the same. So from there, you can find theta 2 as shown here as a ratio. Do you see that?
Yeah.
So
even though it's a bigger gear, the arc length is the same as a small one?
yeah, because it will move the same time, right? So it will
okay.
move much, much slower, correct? So the angle through which the bigger one will go is very small, which will be as calculated in this particular case. Does make sense to you?
Yeah.
Extremely important question from test point of view. Is it okay?
Mhm.
So that's fine. You can explore more, see more videos, right? We'll end the class here and feel free to share your questions. Okay?
Okay.
Thanks and all the best.
Thank you. Bye, sir.